Morning students, today we discuss about introduction about compiler design. Introduction about compiler. So first, before going to that our content, what is meant by compiler? The compiler is nothing but it is a program which converts high-level language program into equivalent low-level language program. So compiler is a computer program that translates a program in source language into equivalent program in a target language. The source program code is a program code written in source language or high-level language. We call it as generally high-level language. The target code or target program is written code in a target language in terms of machine understandable code or sometimes in terms of assembly level language code. So the particular diagram explain about the compiler. The source program is input. The compiler will translate into the equivalent target program. Sometimes the compiler will also produce an error whenever the error message will be generated with if the source program which contains any other errors. So the compilation process will be carried out in 6 different phases. Nothing but your lexical analysis, which is called as scanner process, syntax analysis, we call as parser process, semantic analysis, we call as semantic analysis process, intermediate code generation, code optimization, and code generation. So out of these one, what are the steps? Each and every stage having their different stage levels. So given source program is input to the scanner, it will produce a stream of characters that is given as a input in a source program in terms of stream of characters. Your source program, which is implemented into scanner, the scanner will produce as a output of a stream of tokens. It's produce a stream of tokens. That particular stream of tokens are input to the parser, that means syntax analysis. It will produce the syntax tree or parser tree. So the parse tree also is input. This is a flow. The parse tree is input to the semantic analyzer. The semantic analyzer will also perform some logical computation process and will produce the annotated parse tree. This annotated parse tree is input to the intermediate code generator. The intermediate code will be generated. From this intermediate code, we have to implement some optimization technique. We finally will get the optimized intermediate code. From the optimized intermediate code, we will get the code generator. As a target code will be generated. The target code having some record for optimization means we also produce some optimization technique in the target code. Finally, we'll get the final target code. These are all the 6 different phases in the phase of compiler. Each and every phases what are doing functionality will be discussed in the upcoming slides. So some data structures are implemented here: symbol table, literal table, and parse tree. So in this literal table, in the symbol table, the symbol tables are identified. The identifiers are names, or variables, or constants, which is stored in the symbol table. So the symbol table informations are stored the associated corresponding identified variables. Information associated with the different type of identifiers can be different. So information associated with the variable name, variable type, and address are also to be stored. Information associated with the function means the function names, types, and return values, parameters, addresses are stored. So symbol table having. Now the symbol table which contains what are the variables are using in the particular program, everything will be stored, and what are the functions are utilizing in the program, this corresponding associated attributes, everything will be stored in the symbol table. The symbol table accessed by every phases of the compiler. So scanner generator, parser generator, intermediate code generation, code optimization, code generation. Each and every phases can be accessed in symbol table because the scanner, parser, semantic analysis are put the meaning of symbol table entries. So the first set of analysis phases are everything stored in the symbol table. The semantic analysis store the more information. In the example, data type is also stored in the symbol table. The intermediate code generator, code optimizer, and code generator use the information in the symbol table to generate the appropriate code. So with the help of symbol table only, the code, intermediate code will be generated their target code. So mostly the symbol table are utilizing in the hash table efficiency. Hash table of concept we are implemented with the help of the efficiency of the particular process, efficiency of the particular compiler. Parse tree. So parse tree is nothing but it's a syntax dynamically allocated pointer based structure. So each and everything is dynamically we have to allocate it. So pointer based structure means we have to start the particular, draw the particular parse tree in the root node to leaf node, the corresponding root parent to child relationship, child to parent relationship should be maintained. So information for the different data types related to parse tree need to be stored somewhere. So the parse tree related information, everything will not only stored in one particular location, it will be stored in the different locations. Nodes are variant records storing data information on different data types. Scanner, first step will be scanner generator. Scanner generator is nothing but a lexical analysis space. So lexical analysis will be carried out. The scanner read the stream of characters, that is a source program, and put together in some meaningful information. It will be produce a consecutive a stream of tokens. So it produces the stream of token for the next phases of the compiler. So it produces the token. So next phase will be the parser generator. The parser generator gets a stream of token from the scanner and determines the syntax or everything is present in a correct manner or not. If the programming structure will be verified with the help of the context-free grammar concept. So the program structure, syntax, everything will be verified. It will be produced as a syntax errors. Syntax synthetic structure will be generated. So it produces the data structure is called as parse tree or abstract data type, which describes the synthetic structure of the particular program. Semantic analysis. Next phase is semantic analysis. The semantic analysis will produce gets the parse tree from the parser together with the information about some synthetic elements. It determines if the semantic or meaning of the program is correct or not. The semantic static of the semantic analysis work will be semantic of program that can be checked the reading of the program only. Upon the semantic analysis, everything will be based on the given programming structure. From the syntax tree structure, the programming concepts, everything will be implemented in the correct manner, and as well as you have to verifying the data type checking process will be carried out. The syntax of the language which cannot be described with the context-free grammar. So mostly the semantic analyzer does type checking operations. It modifies the parse tree in order to get the semantically correct code. Suppose we need to be verifying the type checking, so we need to be convert some data type checking process means automatically int to real or int to real to int process will be carried out. Next, intermediate code. So this is your fourth phase of the phase of compiler. The intermediate code generator take the parse tree from the semantic analyzer, generate a program in the intermediate language. In some compilers, our source program is translated into intermediate code first, and then intermediate code is translated into target code. Some other compilers will source program is translated directly into target code. So some of the, which depends upon the compiler, the intermediate code will be generated. So intermediate code, by using the intermediate code, how to write the intermediate code from the parse tree. So from the parse tree, from the bottom to top approach, each and every node will be evaluated and converted into 3 address code format. This particular 3 address code format is nothing but your intermediate code language. So intermediate code having some specific 3 rules we must to be satisfied each and every intermediate code. First one, maximum of 3 address references only using. Second one, minimum 1 temporary variable must be utilized, and minimum at least 1 operator must be used in each and every production. So these are the 3 important rules for to write the intermediate code. So the front end of the, so okay, so analysis phase. So first 3 phases are analysis lexical, that means scanner, parser generator, semantic analysis. Both are all 3 rules, 3 analysis phase we called as front end of the compiler. Scanner to intermediate code generator can be used for error compilers. Rest of the remaining code generation and code optimization phase we called as back end of the compiler. That means code optimizer and code generator. It is required for target code. So one of the popular intermediate code we are utilizing 3 address code format. The 3 address code format in the form of x is equal to y operator z. So identifier 1 equal to identifier 2 operator identifier 2. Code optimization. So code optimization means it is possible to reduce the number of code in the intermediate code from the intermediate code level. So replacing an inefficient sequence of instruction with a best sequence of the instruction. So you can do code optimization, you have to implement in two ways, machine dependent and machine independent. So machine independent optimization is entirely different from machine independent optimization. So from this optimization phase, what we doing means we need to be remove the inefficient sequence of code. The flow of execution may be varying. So may a flow of execution we have to we should to rearranging first point. Otherwise, we need to be eliminate the unwanted code is also unreachable code is also possible to eliminate. So these are the points for replacing an inefficient sequence of instruction with a better sequence of instructions. Sometimes it's called as code improvement technique. Code optimization can be done in after semantic analysis, after intermediate code generation, after code generation. There are 3 different levels we are possible for code optimization after the semantic analysis, code intermediate code and code generation. Code generator. So code generator means the target code will be generated. So it takes either intermediate code or parse tree as an output. So intermediate code or parse tree as an input and produce the target code. This is your final code generation level. So next one, error handling and error recovery concepts. So error can be found in every phases and their compilation. So the compilation process, we are identifying their errors and as well as verifying their syntax. So error found during the compilation is called as, during the compilation process, the error called as static error. Error found during execution called as dynamic errors. Compilers need to detect, report the error, recover from different source programs. Errors handles are different in different phases of compilation. Error handling and error recovery mechanisms are each and every phases. They are having the different methodology, different approaches are implemented. So that's all about your phases of compiler. Thank you, students.